We'll be looking at the question 18, June 23 paper. In this question, it's looking at the enthalpy change of combustion. And you're given some experimental data. So you've got 150 grams of water. You've got the temperature has increased by 10.5 degrees. And the spirit burner has decreased by a mass of this much. What you're doing, you are burning heptane. So your apparatus looks something like this. You've got heptane in a spirit burner. You're lighting it, and it's heating a container of water. You've got 150 centimeters cubed of this water here, and you've got heptane burning. You're measuring the temperature change, which is increased by 10.5 degrees. And what we're trying to do is we're trying to determine the enthalpy change of combustion of heptane, and the units are kilojoules per mole. What we're going to do, we're going to use the expression Q equals mc delta T. M times C times delta T. Now, a reminder of the units, Q is the energy change, which is in joules. M is the mass of water. And what we do, we assume 1 centimeter cubed of the water or the solution is equal to 1 gram. They've already given us the mass of water, which is 150 grams. We got the specific heat capacity of water. And this is a value you need to learn off by heart, 4.18. And what's really interesting, with specific heat capacity of water, what you need to do is understand the units. By the way, this value is given in the data sheet, but it's good to know off by heart. And the units of this is that 4.18 joules of energy is needed to heat 1 gram of water by 1 degree Celsius or 1 Kelvin. So you've got that. Temperature change is in degrees Celsius. It can be in Kelvin, the temperature change as well. Whether it's in temperature change in Kelvin or degrees Celsius, it doesn't matter. So we've got this formula, and let's use the data that's available to us in the question and plug it in and see what we get. So M is 150 grams of water times 4.18 multiplied by the temperature change, which is increased by 10.5 degrees Celsius. Let's work this out. That's joules of energy. Now, if you think about it, what we're trying to do, we're trying to get from joules to kilojoules per mole. How do you convert joules into kilojoules? You divide by 1,000. So let's divide that by 1,000 now. That gives us 6.3835 kilojoules. And now to work out the moles, we're given the moles of the spirit burner here, which is the spirit burner decreased in mass. That's the mass difference. So it's 0.133 divided by the molar mass of heptane, which is over here. What would that be? 7 times 12 plus 16 gives you exactly a 100. That's the molar mass. That gives us 0. Divided by 10 divided by 100 moles. So all we do for the last step, 6.3835 divided by 0.00133 is equal to 1 moment. 150 times 4.18 multiplied by 10.5. Oh, I wrote this the wrong way around. Excuse me. Six five 8.3.5. So we divide that by 1,000, 6.5835 kilojoules. Divide that by the number of moles, 0.00133. That gives us 4950 kilojoules per mole. You see, because the temperature has increased by 10.5 degrees, this is an exothermic reaction, and the sign is essential to get the full marks. Minus 4950 kilojoules per mole. Moving on. In this question, you've got what you're doing here is working out. This process is known as cracking, where you're getting a long hydrocarbon chain and breaking it into a smaller alkane and a smaller alkene. This reaction, you've got the enthalpy change of the reaction here, and they've given you enthalpy change of combustion values. So what we're going to do, we're going to create a Hess's Law cycle. So you've got C9H20. We know the enthalpy change of this. That's the enthalpy change of the reaction. Now, combustion is the enthalpy change. So if we were to burn completely in oxygen, the reactants and products, it gives us the same combustion products of 9 CO2 and 10 H2O. These are your combustion products. Notice the arrows are going down. Now, they've given you for nonane minus 6171. They've given you for ethene, which is 2 times minus 1411. And you're trying to work out what pentane is. Let's say plus X, which is the enthalpy change of combustion of pentane. That's what we're trying to work out. So Hess's law states that the overall enthalpy change of a reaction, let's call this root 1, is going to be the same irrespective of root taken, whether you take root 1 or root 2. So root 1 is going to be plus 186 is equal to minus 6171. You're going with that first arrow, this one over here. You're going with that arrow, so it's going to be minus 6171. And then you're going against this arrow. You're going against. And because you're going against, we put a big minus there. We open a bracket. It's going to be 2 times minus 1411 plus x is what we're trying to work out. With calculations like this, be very careful and use brackets. It helps a lot. So rearranging the equation, times minus 1411. So if we just neaten this up a bit, minus 6171 minus, actually that now becomes a plus 2822 and then minus x. We just got rid of the brackets. And we want to bring everything else on the other side. So plus 186 plus 6171 minus 2822. That gives us x is equal to wait a minute. Minus, bring that to the other side. So I need to got my sign mixed up here. That's right. That's right. So it's going to be reactants minus products. That's right as well. Minus, minus. Yep, that line is correct. So, okay, I think, yeah, I see what's to happen here. So what we're going to do, we're going to bring x to the other side. We're going to bring x to the other side. Plus, whatever you do to one side, you do to the other. Let's do plus x, x plus. And we got x will equal minus 6171 plus 2822, and then minus 186. And you'll find x is equal to minus 3535 kilojoules per mole. Yep, and the mark scheme supports that. In this question, it's asking you, ethene can be produced from ethanol, as shown in reaction 2 below. If you look over here, you've got 1 mole of a gas that's producing 2 moles of a gas. So the degree of disorder is actually increasing. You're getting 1 mole of gas going on to produce 2 moles of gas. The degree of disorder is increasing. So we will say, to predict the sign, it will be the entropy change will be positive. Positive because it's gaining entropy, because it's gaining disorder. Why is it gaining that disorder? Because more moles of gas are being produced. You must include both points, that it will be positive, and it says explain your reasoning. Give a reason why that is. Okay. Next question. This is you're using the Gibbs equation here, Gibbs free energy. That's where the delta G symbol means, referring to Gibbs free energy. This delta G equals delta H minus T delta S. We're going to be using this. Reaction 2 is repeated. The enthalpy change and the entropy change can be assumed to be constant at different temperatures. Figure 18.1 shows values of the free energy at different temperatures. And what I've done here, I've already sort of drawn a line of best fit for the points plotted. And we're going to be using this to extract some information that we need. It says, using the graph, draw a line of best fit on the graph. We've done that in the red line. In the exam, you are only allowed to use a black pen, so don't use colors. I'm using colors for illustrative purposes, but please use a black pen only. It's asking draw the line of best fit. Determine the delta S. Determine the minimum temperature at which it's feasible. And determine the enthalpy change. You see, to work out the gradient, what you're doing here now, if we've got delta G divided by T, temperature change, delta S, constant temperature. Bear with me, class. Just having a little think about something. Now, I'm like a deer in headlights because from the graph, it's saying that delta G, T delta S, delta H divided by T, and I'm not sure why the gradient represents the entropy change. What's going on here? The entropy change can be assumed to be constant at different temperatures. T, we've got that, we've got the temperature. I'm missing something here. Why is the gradient the referring to the entropy change? Anyway, let's come back to that point. What I can share with you, you see, if you draw these lines of best fit in red, you see it wants us to determine the minimum temperature at which this is feasible. Minimum temperature at which this is feasible. Now you see the minimum temperature at which this is feasible is when delta G is going to be equal to 0. It's going to be equal to 0 over here. And when delta G is equal to 0, the temperature is going to be over here. So we can read that off as 350 Kelvin. This is the temperature at which the minimum temperature at which this reaction is feasible. Now, you see, when the temperature is 0, so let's highlight that here. when it's 0 Kelvin, and you got your delta G is equal to delta H minus T delta S. When T is equal to 0 Kelvin, that means this whole T delta S, that whole thing is equal to 0 now. So at 0 Kelvin, delta G is equal to delta H. And so at 0 Kelvin, delta H would be the y-intercept. And in this case, that's 43 kilojoules per mole. So we've got that. We've got the minimum temperature. We've drawn the line of best fit. Now coming back to the gradient, we can work out the gradient. But I seem I'm puzzled as to why delta H, delta S. Gradient. Anyway, it's saying work out the gradient. And so we can take values, ideally the biggest possible. Let's do 43. So from there to there, and from there to there, 43. So difference of y over x, 43 over 350. That's going to be a minus 43 divided by 350 gives us 0.122857. That's in kilojoules per mole. And if we multiply as kilojoules per mole, and that's a negative value. And I'm still puzzled as to what they're doing here. Why are they converting it into the gradient? Why are they multiplying it by, it's gained entropy, so it's positive. They're multiplying this answer. They're multiplying it by minus 1000 to give you plus 122 joules per mole per Kelvin. Oops, I missed out per Kelvin here. So, in the comment section, I need your help on this. Why is the gradient equal to entropy? Well, mine's gone blank. I'm gonna have to look this up. But class, these are the points. Worked out the gradient, worked out the value for the gradient. You get the marks for that. Line of best fit, minimum temperature, and the enthalpy change. And that is all of question 18. Thank you.